Hi everyone, I am Asudha, Assistant Professor, Department of Electrical and Electronics Engineering in Dandipur Government Institute of Technology, Vellore. In power system analysis, today we are going to see about network graph, bus incidence matrix, primitive parameters, bus admittance matrix from primitive parameters. We'll see some basic definitions. The geometrical interconnection of various branches of a network is called the topology of the network. The connection of network topology shown by replacing all its elements by line is called graph. So, what is network? Network is nothing but interconnection of various branches. So, the network topology when it is replaced by line is called as graph. A linear graph consists of set of objects called nodes and another set called as elements, such that each element is identified with an ordered pair of nodes. An element is defined as any line segment of graph respective to the characteristics of components involved. A graph in which a direction is assigned to each element is called an oriented graph or a directed graph. The connected graph is the graph where at least one path exists between any two nodes of the graph. This path is disregarding the orientation. So, a connected graph is nothing but at least one path should be there between any two nodes of the graph. Cut set. It is a set of branches of a connected graph G which satisfy the following conditions. The first one is the removal of all branches of cut set causes the remaining graph to have two separate unconnected subgraphs. The second one is the removal of all but one of the branches of set leaves the remaining graph connected. 3. It is a connected subgraph containing all nodes of the graph G but without any closed path. There is one and only one path between every pair of nodes in a tree. The elements of trees are called as twigs or branches. In a graph with n nodes, the number of branches is calculated by b equal to n minus 1. Core tree. The set of branches of original graph G not included in tree is called as core tree. The core tree could be connected or non-connected, closed or open. The branches of core trees are called links. The number of links L equal to E minus B, where B is nothing but n minus 1. So, L number of links is equal to E minus n plus 1. We'll see the primitive network. It is a set of unconnected elements which provides information regarding the characteristics of individual elements. It can be represented both in impedance and admittance form. In impedance form, it is represented as the voltage source ERS connected in series with the impedance ZRS. Where ER is the receiving end voltage and ES is the sending point. The VRS is the voltage difference between ER minus ES. Coming for admittance form, here the voltage source is represented in terms of current source. So, ERS is converted in terms of IRS and this current is nothing but IRS is the sending end current, which is the IRS plus current which is flowing in this current. So, what is VRS? VRS is nothing but again ER minus ES. Let us see how to form the admittance matrix. Admittance matrix can be formed by two methods. One is inspection method and other is singular transformation. Let us see the matrix of n number of buses. Y bus, which is represented in the matrix where if there are n number of nodes or n number of buses, it's represented as y11, y12 up to y1n. Similarly, it is y21, y22, it goes up to y2n, and yn1, yn2, yn. Let us see how to find the diagonal elements and off-diagonal elements. In inspection method, if there are n-bus system, the diagonal elements of y-bus is given by yii equal to summation of j equal to 1 to n yij. Off-diagonal elements of y-bus is given by yij is equal to minus y. In singular transformation method, y-bus is given as A transpose into primitive admittance into bus incidence matrix, where Y is the primitive admittance and A is the bus incidence matrix. Let us see one simple problem how to find the Y-bus. Consider the impedance diagram in which the system parameters are given in per unit. The system admittance can be written in per unit as y11 equal to y22 is equal to minus 4j, y12 is equal to minus j5, y13 equal to minus j4, y23 is equal to y34 is equal to minus j2.5 and y24 is equal to minus j2. Let us see the problem given. This is the circuit diagram shown. It consists of bus 1, 2, 3 and 4. To bus 1, it is connected with the transformer T1 and generator from generator G1. G2 again with the transformer T2 and it is connected to the bus 2. So it is a EG1 by this Z11 or it can be in terms of admittance also. So this transformer impedances are connected as shown as Z11, which is connected to bus 1, and the transmission line impedances between 1 and 3 is shown as Z13. Now bus 1 and 2 is connected and to the transmission impedance of Z12. Similarly, generator G2 is represented as EGS and the impedance and transformer is represented as Z22, and this is at node point bus point 2. Between 2 and 3, the transmission line impedance is represented as Z23, and between 2 and 4, the transmission line impedance is shown as Z24, and between bus number 3 and 4, it is Z34. This is the impedance diagram. This impedance diagram can be converted into admittance diagram by converting the source to voltage source to current source. Here, a voltage source in series with Z11 is represented as a current source in parallel with the Y11. Similarly, EG2 is represented as with the current source in parallel with Y22, and Z13 is equivalent to 1 by Y13 and Z12 is 1 by Y12. Similarly, it has been shown, and now we have Y11, that is between Y11 is unequal to Y22 is minus J4, 4 ohms. Between 1 and 2, Y12 is minus J5 ohms. Between 1 and 3 is minus J4 ohms. Between 2 to 3 is minus J2.5 ohms. And between 2 to 4 is minus J2 ohms. So, at node 1 or at bus 1, the impedance which is connected are y11, y12, y13. Whereas the off diagonal is between 1 and 2 is bus minus y12. Again, between 1 and 3 bus is minus y13. And there is no impedance or the admittance contained between 1 and 4. So it is represented as 0. Similarly, for second row, it has been filled. And all the diagonals are nothing but this summation of j equal to 1 to n yij, and off diagonal elements are represented as like this, forming the matrix. Substituting the values of y11, y12 and everything, we will form the y bus output like this. This is the method to find y bus by using the inspection method. With this, let me stop the section and we'll see in the next section the other topic. Thank you.